Hello everyone. Let me just check if I'm audible and visible to you all, guys. Yes, I'm sorry for the delay. Good morning everyone. Yep, sorry. Okay. Hello, good morning. Yes, I know time is money and I'm sorry for starting a little late. I got stuck in traffic. Okay. Okay. Hello everyone. Good morning Aisha. Good morning Sonakshi. Hi Night Fury. Yes, everything is all right. Good morning. Okay. So without further delay, yeah, time is money, as who said that? Hold on a second. Okay, good morning. Okay, so let's start. Good morning everyone. I hope your morning is going good actually. Okay, so what are we going to study today is the most repeated PYQs of solutions and electrochemistry. If you have done a revision, that's okay. If you haven't done it, we'll do through the questions. Okay. Yes, Akshat, you can watch this session if you're preparing for COMEDIC. The question level is different for COMEDK and for KCET, but if you start from KCET and then you can go to your COMEDK preparation, okay? The syllabus is similar, almost same. Okay, so let's start. First, let's start with the chapter solutions. Okay, this is the state questions again. Let's start with the chapter solutions. Okay. I'll give you, yes. Am I audible? Just any issue going on? Yes. Is it visible, audible, right? Okay. Yes, correct. So the first question is, variation of solubility with temperature for a gas in liquid is shown by the following graphs. The correct representation will be. Okay. So my dear students, we are talking about the solubility of gas in liquid. When we talk about solubility of gas in liquid, so just imagine this is a liquid, right? This is a liquid solution, any solution we have, right? And in this we are trying to solubilize gas molecules. Okay, so what should be the ideal conditions? Good morning everyone. Increase volume. Okay, I will talk a bit louder, I think. Hold on a second. It's audible, I think. C, B, yes, B, C. Okay, so my dear students, one thing you need to remember, that when you're trying to solubilize a gas in liquid, that process is, when you are trying to solubilize a gas in liquid, that process is exothermic in nature. Dissolution of gas in liquid is exothermic in nature. Exothermic means heat is getting released, right? So when heat is getting released, this is the process of solubility, of dissolution of gas in liquid. Now what will happen if we increase the temperature? You know Le Catelier principle, right? You all know Le Catelier principle, right? So according to Le Catelier principle, if a system is in equilibrium, this system is in equilibrium, the system will try to stay in equilibrium and oppose any change applied to it. So in this case, what we are doing, we are increasing the temperature. Let's say, right? If you increase the temperature, what will happen? The reaction will go in backward direction. According to Le Catelier principle. Simple principle, you know, like Newton's law of motion. An object in rest will like to remain in rest, and in motion will like to remain in motion. Similar to that is Le Catelier principle. It applies to system in equilibrium. According to that, any system that is at equilibrium will try to stay in equilibrium and oppose any change that is applied to it. Okay, that's a simple form. Here what is happening, as this process is exothermic in nature, if you increase the temperature, what will happen? The equilibrium will shift in backward direction, right? So that means on increasing temperature, solubility, see here liquid plus gas is there, solubility. But if the reaction is going in backward direction, what will happen? We'll getting gas only. That means solubility is decreasing. What is happening here? Solubility is decreasing. So which of the following plot decreasing? Which of the following plots suggest that solubility versus temperature graph have a negative slope? Option B. Some of you are answering option C. Poll you want? I'll ask if we can add the poll. Okay, let's see if it gets added. Yes, hi everyone. Some of you are answering A. No, the correct answer is B. See, only in this graph, solubility versus temperature, the solubility is decreasing on increasing temperature, right? On x-axis temperature is increasing, right? So the solubility is decreasing with respect to temperature. Here it's a hyperbolic graph, here it's increasing, and here it is constant, and these three cases are not possible for this. Yes. Hi Mir Zafar, my name is Ekta. I'm your Ekta ma'am. Okay, yes, so everyone answering B, it is correct. Next question. A mixture of phenol and aniline, so let me just draw it for you. This is phenol and this is aniline, shows negative deviation from Raoult's law, right? You know what is negative deviation from Raoult's law? So negative deviation means when you mix two solutions, let's say, when you mix two solutions A and B, and the intermolecular forces of A and B are greater than or stronger than AA and BB, right? If you have a solution of all the A's, pure A and pure B, the intermolecular interactions that are in A and B are lesser than the intermolecular interactions between A, B, right? That is negative deviation. So, what do you think should be the answer? Now you have the poll also. See, yes. So what is happening here, as a mixture of phenol and aniline is showing negative deviation from Raoult's law, that means the intermolecular forces are really strong. Now what kind of intermolecular forces will be here? Just see. OH, there is NH, right? So there will be a hydrogen bonding. What kind of hydrogen bonding? As it is between two different molecules, it will be called intermolecular hydrogen bonding. So what kind? I'll just show you. It will be okay, like this, intermolecular hydrogen bonding. See, okay. Yes, so the reason is due to the formation of intermolecular hydrogen bonding, correct? And positive deviation, when the intermolecular forces between A and B, when you mix two solutions, the intermolecular forces is less than AA and BB. These are your pure solutions, pure A and pure B, okay? Right, this is negative deviation and this is positive deviation from Raoult's law, right? So I don't know yet, it will depend on the questions, right? As we are solving, we'll get to know. Like, dissolve, like. Yeah, it's a different thing. We are not talking about solubility here. We are talking about Raoult's law. That means we are talking about vapor pressure. This question you want me to explain again? Okay, so the question is saying that phenol and aniline mixture is showing negative deviation from Raoult's law. What could be the reason for it? So negative deviation from Raoult's law is only shown when you mix two solutions and their intermolecular forces are really strong, stronger than their individual components, right? So here this is solution of, let's say this is the solution of phenol and this is the solution of aniline. So in all the phenol molecules, the intermolecular interactions, and in all the aniline molecules, the intermolecular interaction, it is lesser than the intermolecular interactions or intermolecular forces between one phenol and aniline molecule. Okay, that means it is showing negative deviation, and it is generally shown, negative deviation will be shown for the cases where hydrogen bonding is involved. Okay, where hydrogen bonding, and as you know we are mixing, so obviously two different molecules will be there, so it will always be intermolecular hydrogen bonding. Okay, intra happens for like within the same molecule, if you are talking within the same molecule. Okay, I got erased I think. Okay, so the reason here is intermolecular hydrogen bonding. As you can see, it happens like this between two different molecules, the hydrogen bonding. Okay, I hope Amaya your doubt is clear now. At this point, this time should we focus on reading NCERT line by line? To be honest, if you have, just a genuine suggestion, if you have read NCERT, only then start NCERT. If you have not touched it yet and it is your first time touching it for now, don't do it. Focus on questions. Okay, solve as many questions as you can. Okay, PYQs, mock test, KCET based questions, anything that you find, solve questions, revise and solve questions, because time is of essence for you, right? We have just 1 month, less than a month actually. Okay, so not even touched. Oh, if you haven't touched it, then don't start now. Whatever notes you have from wherever you have studied, revise those notes and solve the questions, because questions will give you a clear-cut idea of how to attempt, what kind of problems will come, right? So example here, they asked about the bond, what kind of bond is involved. So from Raoult's question like this might come. If it's positive deviation, then obviously, see, depends. Positive deviation means the intermolecular force are weak, right? Okay, I'll give you an example for positive deviation. We have water and ethanol. A mixture of water and ethanol will show positive deviation from Raoult's law, right? Now, why will it show positive deviation? Simple. In water molecule, we have hydrogen bonding. In ethanol, we have hydrogen bonding, right? But weak. It's a weak hydrogen bonding. Why? Because of this hydrophobic part. Because of this hydrophobic part. So what will happen if you mix both of them? Due to this hydrophobic part, the overall hydrogen bonding, it's supposed to do hydrogen bonding, right? Oxygen here, hydrogen here, it is supposed to do hydrogen bonding, and obviously to some extent it will do hydrogen bonding. But what happens here, when you mix water and ethanol, this R group, this hydrophobic part comes in between and it prevents the hydrogen bonding. Basically, if the hydrogen bonding was supposed to, let's say, if it was going at level 10, it will only happen at level 1 because of this hydrophobic part. Okay, it weakens the hydrogen bonding between water and ethanol. Okay, and that's why it shows positive deviation. Positive deviation means vapor pressure is more, high vapor pressure, highly volatile, right? I hope you know the basic concept for that. Okay, right? So this is an example of positive deviation. Here what is happening, again, we are forming hydrogen bonds, but weaker hydrogen bonds, okay, because of this hydrophobic part. Then depends what kind of options you are given, okay. Okay, let's go. Understood? So let's move on to the next question, and this correct option is C. I saw all of you answered C. Next question. The minimum elevation in boiling point is given by a solution of. Now you see, all these solutions have same concentration, right? All are 0.1 molar. Now you need to tell me which will have the minimum. The thing is minimum. So my dear students, as we know, this elevation in boiling point is a colligative property, right? It is a colligative property. That means it will depend on the number of molecules of solute, number of molecules of solute. right? Now, more the number of molecules of solute, more will be the, in this case we are talking about elevation in boiling point, right? So more the number of solutes, more will be the elevation in boiling point, right? More will be the elevation in boiling point. So let's see. You know one thing, I. This I, do you remember? Van 't Hoff factor, right? Do you remember I? B minimum. Okay, so this is Van 't Hoff factor. It tells us about the association or dissociation, right? The number of molecules involved if a component, if a molecule associates or dissociates. This is majorly used in calculating colligative properties. We have how many colligative properties? 4. We have relative lowering of vapor pressure, we have elevation in boiling point, depression in freezing point, and osmotic pressure. Okay, so we are talking about elevation in boiling point here. So all these colligative properties have one thing in common: they depend on the number of molecules of solute or amount of solute. They depends on the amount of solute, right? More the amount of solute, more the amount of solute, more the amount of solute, more will be the elevation in boiling point in this case. Now let's see this Van 't Hoff factor for NaCl. When NaCl is present, it will dissociate as Na positive and Cl negative. How many ions we are getting? How many? 2, right? So the Van 't Hoff factor for this is 2, right? Okay, now let's move on to urea. Urea is NH2, CO, NH2. Okay, this is urea. What is the Van 't Hoff factor for this? Does it dissociate, associate, do anything? It remains as it is. The Van 't Hoff factor is 1 for urea, right? Okay, how many molecules in MgCl2? Let's see. MgCl2 will dissociate as Mg2 positive and 2Cl negative. So 2 plus 1, the Van 't Hoff factor is 3. Then Al2SO4 thrice, it will dissociate as 2Al3 positive plus 3SO4 2 negative. How many? 3 plus 2, 5. The Van 't Hoff factor will be 5 in this case. Clear? Yes. Okay. So, which will have the minimum elevation in boiling point? As the Van 't Hoff factor, as the amount of solute is the least for urea. It is the least for urea. Thus, urea will have the minimum elevation in boiling point. And yes. Okay. Now, which will have the highest elevation in boiling point? Which will have the highest elevation in boiling point? That will be your option D. Which doubt you have? Let's solve D. Yes, D will have the highest elevation in boiling point. Okay. Now let's move on to the next question. Any doubt you have, you can comment them and I'll answer it out. Don't worry. Okay, this one is actually interesting. If you answer this correctly, I will know you are studying. Okay, let's see. Choose the correct statement. You need to choose the correct statement. The first statement is KH. Firstly, KH is Henry law constant. Like KH is Henry constant or Henry law constant? Henry's constant. So Henry constant, this Henry law's constant, KH tells us about solubility. KH tells about solubility. If is maximum D. Okay. For this, I'll give you a hint. There are more than one correct options. For this question, there are more than one correct options. Okay, so see, KH value. This KH value is related to solubility. This KH value is related to solubility. How? It is related inversely to solubility, right? So KH is inversely related to solubility. If the KH value is high, the solubility, whose solubility? Solubility is of gas in liquid. This is gas in liquid. Clear? So the solubility of gas in liquid is inversely related to KH value. That's what we know already, right? Okay, now let's see the options. KH value is same for a gas in any solution. No, it's not. It depends on the nature of the gas and solvent and also on temperature. So obviously it will vary. It depends on the nature of the gas. So it will vary in different solutions. It's not same. So this is incorrect. Higher KH value, more the solubility. No, it's also incorrect, right? Because KH is inversely related to solubility. Henry law constant is inversely related to solubility of gases in liquid. So that means this statement is also incorrect. KH value increases on increasing the temperature of the solution. Now this is interesting, right? Because there is no correct relation given here. Okay, so I'll tell you, you know solubility and temperature relation. First question we did. Solubility is related to temperature. How? It is inversely related to temperature. If you increase the temperature, solubility of gases in liquid decreases, right? So if you increase the temperature, the solubility will decrease. And you know solubility is also inversely related to KH. Here you can see the direct relation. That means KH is directly proportional to temperature. So if you increase the temperature, KH value will also increase. So that means this statement is correct. Last, easily liquefiable gases. B and D. No. Good morning, Arif. Yes, C and D, Asha. Correct. Yes, inverse. Yes, temperature is related inversely. Now, easily liquefiable gases usually have lesser KH values. Easily liquefiable. What do you mean by easily liquefiable? That means gases that can easily convert into liquid. That means gases that can dissolve or that can solubilize in liquid, right? Those gases will be easily liquefiable. So they have usually lesser KH value. Easily liquefiable means highly soluble. Highly soluble gases. Clear? Highly soluble means the KH value will be low, right? Because the relation is inverse. The relation is, as the relation is inverse, when we are talking about easily liquefiable gases, that means they can be easily converted into liquid. That means they are very much soluble in liquids, right? And if solubility is high, then KH value is low. That is the direct relation we have, right? So this is also correct. So for this question only, the correct answer is C and D. Only for this question. The correct answer is C and D. Correct. Volatile, yes. So for no. For NEET, you need, the syllabus is totally different from for NEET. You need much more preparation than this one. Okay, the KH values for 1, 2, 3, 4 gases are given. The increasing order of solubility. Simple. As we know, KH is inversely related to solubility. So if we increase the KH value, if we decrease the KH value, the solubility will increase, and we need to give the increasing order of solubility. We need to give the increasing order of solubility. What should be the correct order? Okay, let's start with from high KH value to low KH value. That means this is the increasing order of solubility. Why? As KH value is decreasing, solubility will increase. Clear? As KH value is decreasing, okay, good. As KH value is decreasing, the solubility is increasing. So we'll start with the higher KH value, which is the highest here, 40.3. 40.3. Okay, let me just clear it. 40.3. This is for argon. I'll write 1 here. Okay, after that 1.67, which is for 2 carbon dioxide. Then 0.413, which is 4. And final 1.83 times 10 raised to power minus 5, which is for 3 formaldehyde. So the correct answer is option A. 1, 2, 4, 3. That is the correct sequence. Okay. one more thing, when you are attempting questions like these, sometimes you can just figure out, you know, the least will be for 1, so that means option A, option C and D will be correct. Then the next one will be for 1.67, which is for 2. So which is option have after 1? We have 2 here only. So that means this is the correct answer. You can save some time because you have only 60 minutes to solve all these questions, 60 questions in 60 minutes, right? So that's how you save some of your time. Okay, can you explain D? Option B. Yes, correct answer is option B. Elimination. Yes, that is elimination, and you need that for your KCET actually. Okay, can you explain option D in brief for previous question? Hold on a second, which question? Okay. Easily liquefiable gases have lesser KH value. So what does that mean? Okay, Sonakshi, right? Okay, see, so Sonakshi, easily liquefiable gases means that the gas can be easily converted to liquids. And how do you convert gases to liquids? Gases converting to liquid means gases are soluble in liquids, right? That means easily liquefiable gases are highly soluble. They are highly soluble. Highly soluble means they have high solubility, right? How do you measure solubleness, right? You may say it is highly soluble, that means it has high solubility, and we already know that high solubility and KH value are inversely related. So if the solubility is really high, that means the KH value is low. That's what this statement says. Easily liquefiable gases have lesser KH values. Okay. One more thing I want to ask you, what are the criteria if you want to liquefy a gas? There are 2 criteria by which you can liquefy a gas. What are the 2 criteria? I hope, Sonakshi, it is clear. Easily liquefiable means highly soluble gases, and it is inversely related to KH. That means it have lesser KH values. Okay, next question. Yes. Okay, we have solubility of gas in liquid increases with. Okay, this is the same as the question I asked. What are the criteria for liquefaction? This is the same question, okay? To liquefy gases also and to solubilize. Solubility means you are solubilizing where? In liquids, right? So you are converting gas into liquid only. Clear? C, A. Okay, I'll see your, okay. So when you are trying to solubilize a gas in liquid, one thing we know from our question first we solved, right, that it is inversely related to temperature. It is inversely related to temperature. So solubility of a gas increases with decrease in temperature, right? Solubility is inversely related to temperature. So that means if we want to, the solubility of gas increases, the increased relation we are seeking. So if solubility is increasing, that means the temperature is decreasing. That means the temperature is decreasing. Clear? So one thing is clear, which has decrease in T. So it will be either option A or option B. Now let's see. Pressure. How is pressure related to solubility? How is pressure related to solubility? A. Yes, correct. All of you are answering increase of pressure, decrease of temperature. Correct. So yes, when we increase the pressure, the solubility increases. Why the solubility increases? Because you see, if you have like liquid here and gas here, and somehow if you increase the pressure, there will be more contact between the gas and liquid, right? There will be more contact. As there will be more contact, the gas will get more soluble, right? The chances of solubility increases, right? The chances of getting soluble in liquid increases. That's why it increases with pressure and decreases with the temperature. So I can write here like this. Clear? Okay, so that means option A. And all of you, how many of you answered option A? Correct. A. Yes, so all of you answered A. Let me just check once. Yep, all of you answered A. Why you answered B? The correct option is A. When you want to liquefy a gas, even when you want to liquefy a gas, the criteria is you increase the pressure and you decrease the temperature. When you want to liquefy a gas, you increase the pressure and you decrease the temperature, right? Same is for this solubility. Next question. Relative lowering of vapor pressure of a dilute solution of glucose dissolved in 1 kilogram of water is 0.002. The molality of the solution is the molality of the solution is. Thank you. Okay, answer this question. Now we are talking about relative lowering of vapor pressure. How is relative lowering of vapor pressure? How do you determine that? We know that relative lowering of vapor pressure, let me write it like this. P naught is the pure pressure, pure solvent pressure. There is a relative lowering. Why? Because we are adding a non-volatile component to that solution. Because we are adding a non-volatile component to that solution, and because of that, the vapor pressure of that solution decreases. It decreases, right? Clear? Okay. And that is equal to what? That is equal to the mole fraction of that component, mole fraction of that non-volatile component that we added, right? How much lowering will be there? It is directly proportional to, or it is equal to, the mole fraction of the component that we added. That is relative lowering of vapor pressure. Now what is given here? The relative lowering of vapor pressure is given. That means this whole quantity is given. That means this whole quantity is given, and we are asked to determine the molality. Okay, just remember what we are given. This thing we are given 0.002. Okay, and molality we need to figure out. Molality. What is molality? Number of moles of solute present in 1 kilogram of solvent. 1 kilogram of solvent. That is molality. Okay, now let's see. Mole fraction we know now. What do we know about? The mole fraction we know, which is 0.002. From this relation, we know that mole fraction is 0.002. Okay, now what do we need? We have glucose dissolved in 1 kilogram of water. Mole fraction is what? Number of moles of that component upon total moles. Number of moles of that component upon total moles. Okay, how many moles of that component are there? We have no idea, but we are given 1 kilogram of water. 1 kilogram of water are how many moles? That's like a universal thing. 1 kilogram of water have how many moles? So we just calculate is, what is moles? How do you calculate moles? Given mass upon molar mass. Given mass divided by molar mass. Given mass is 1 kilogram, which is 1000 gram. Molar mass is 18 gram per mole. So that will comes out to be 55.5. Okay, 55.5 moles. 55.5 moles. Now what will you do? Let's see. Now, okay, one more thing. It's a dilute solution. Dilute solution means the amount of glucose is really less. The amount of glucose is really less. That means here in the denominator, we can just take the number of moles of water only, because the solution is dilute. The amount of glucose is really less. So I'll just write it like N2 by N1. And what is N1? N1 is the number of moles of water. Okay. Clear? Now we know this thing is this, right? So that means this is equals to 0.002. 0.002. Once you determine the number of moles of glucose, what will be the number of moles? Number of moles of glucose will come out to be 0.111. Clear? 0.111. Now if you want to determine the molality, you just substitute it here, which you already know. Number of moles of glucose are 0.111, and the amount of solute, amount of solvent, weight of solvent is 1 kilogram. Okay, so by 1. So that means the molality is 0.111. You would have answered here only. Option C, 90.9. Option C. Yes, the correct answer is option C. Clear? Hello, Ichu. Okay, option C. So how many of you answered option C for question 6 is there? Okay. Okay, Vaishnavi, yes. So I hope you understood it, because we know sometimes the things may not be directly related. Like here we are getting mole fraction, but we are not getting molality. So just don't stress out. Write everything that is given. Write down everything that is given and how to calculate the quantity that is asked. Everything that is given and how to calculate the quantity that is asked, and then you just relate, you go with the flow, it will come out on its own. So what do I know about mole fraction? This is this mole fraction, right? So here if I substitute this value, I'll get number of moles. Now I know molality is number of moles upon amount, right? Amount of solvent. Here amount is already given. Clear? So that's how you approach the questions. There you have little, yes, less time. Calculation, this is calculation. I hope it is visible. It's very easy. This is the number of moles, calculation for water. Okay, and if we multiply 55.5 with 0.002, the answer is 0.111. How to divide? What you are not understanding? How to divide? You don't understand how to divide here or where? This you didn't understand? All clear? Yes, you have to solve the question in 1 minute, but for me I have to explain to you all, because some of you might not have the revision, they would not have studied, maybe or maybe not. Okay, for you, you need to solve it in 1 minute. Your answer should come in 1 minute. As soon as you see the question, you should be able to answer it. Okay. Let's answer this question first. Vapor pressure of a solution containing 18 gram of glucose and this much gram of water is this. Okay, pure water is given. If you add glucose to this, there will be a relative lowering of vapor pressure, because you see vapor pressure, pure water is given. Sometimes you get an idea from the question itself. As the vapor pressure of pure water is given, what will you do? You will apply this. In this place, I can write N2 upon N1 only. Why? Because again, not much amount, 18 gram and 178 gram. 18 gram of glucose added to 178 gram. That's not a big amount. See, you answered B. Okay, yes. Okay. Some of you answered C also. Why C? B. Okay. Yes, C. Okay. Now see, vapor pressure, this is given, P naught is given, which is around 760 torr. Okay, N1, okay, N1 is also number of moles of water. N1 is the number of moles of water, which will be 178.2 by 18. Clear? And N2 will be 18 by, glucose is there, 180. Okay. You substitute all these values here. What do we need to find? PS we need to find. We need to find the PS. Good. You guys are good at calculation. Yes. B is the correct answer. Okay. So I'll just substitute it. And as you all have calculated it before me. Hold on a second. 760 minus PS upon 760 equals to 18 by 180 times 18 by 178.2, and if you calculate this all, the answer will come out to be 752.4 torr. Actually the answer will come out like this: 760 minus PS, this whole will come out to be 8.07 something, right? And if you do this, PS will be 760 minus 8.07, come out closer to 3915. So it's come out 751.2, which is close to this one data. Okay. Yes. C. Why are you answering C? So that is a wrong answer. Okay. Is it clear? How did we calculate it? Relative lowering of vapor pressure, right? And we just substituted all the values. We needed to find the lowering. How much lowering will happen? Yes, if we add this much glucose, 18 gram of glucose and in 178 gram of water. Correct. How much marks should we score to get 10,000 rank in KCET? See, that rank calculation and all that we'll do later on. Ah, thank you. Calculator is not allowed. Yes, this is basic calculation. You can do it. It's easy actually. Yeah, correct. He's rage beating. Yeah. Yeah, I feel that too. Okay, next question. Solute X dimerizes in water to the extent of 80%. 2.5 gram of X in 100 gram of water increases the boiling point by 0.3 degrees Celsius. We need to find the molar mass of X. Okay, answer this question in one minute. I'm explaining till then. Okay, so the question says that it is dimerizing, first thing, and second thing, the degree of dimerization. The extent of dimerization is 80%, which is 0.8. I can write 0.8. 80%, 0.8. Right? Okay. How much amount of solute is added? The amount is amount of X is 2.5 gram. Okay, in 100 gram of water. In 100 gram of water, and the increase in boiling point, that means the elevation in boiling point is given, which is 0.3 degrees Celsius. Okay, Kb is also given, 52 Kelvin kilogram per mole. Okay, molar mass we need to find. We need to find the molar mass of the X, molar mass of the solute. It is dimerizing. The thing is, you can calculate it straight away because you know delta TB equals to KBM, right? And we are given the data almost, but here this formula will not be used. There will be a slight variation to it. Why? Because the solute is dimerizing. That means Van't Hoff factor you have to find out. What do you have to find out? The Van't Hoff factor. The formula also changes in case of association or in case of dissociation. What is happening here? It is association. Two molecules are dimerizing, right? Dimerizing means the solute X is dimerizing. Two molecules are combining, right? Associated molecules are two. The formula in this case for association, what is the formula? You can't write it, I'll write it for you. For association, the I equals to 1 minus 1 by n times alpha. Maybe you have learned that +1 formula, that's also okay. I have learned this one. You can use this and the other one also. Okay, what is N? N is the number of associated molecules. How many molecules are associated? Dimerization, that means two molecules. Okay, number of associated molecules. Alpha is the degree of dissociation or association. In this case, association is 0.8. Alpha is 0.8. So if I substitute these values here, let me just calculate. 1 minus 1 by 2. Number of associated molecule is 2 as dimerization is happening, and alpha is 0.8. Degree of association is 0.8. So I calculated I, it came out to be 0.4, 0.6. It will come out to be 0.6. See. Pole didn't come. Okay. The pole will come. Okay. So after some time it will come. Maybe some glitches there. 0.6. I is 0.6. KB is already given 0.52. Okay. Let me just move the question a little bit. Maybe if I get some space. KB is already given. Clear? Okay, and molality. We substitute all these values here. 0.3 is equals to 0.6 times 0.52 times molality, number of moles of solute, 2.5 by m times how many amount of solvent is 100 gram, convert it into kilogram. Okay, this is your final equation that you have to solve, and you need to find m here. Okay, what is the, and all of you are answering correct. Option, which question is this? Nine. Okay, no worries. So if you solve this, the answer will come out to be 26. M will be equal to 26. Yes. This is question 9. Now the question 10 hasn't come yet. I'll ask the question 10. I hope it is clear. Hello everyone. Okay. Solve this question in 1 minute. Okay, it's a little bit calculation is there, but you can do it. Firstly, check what the question is asking for. The question is asking for freezing point of pure water is 273 Kelvin. You need to find the freezing point of the water sample if we add these two components, AB and XY2. Little bit calculation there, little bit calculation. Okay, you're already answering. I don't think I remember the answer for this one. I'll calculate it with you. Okay. So firstly, we are talking about what do we need to find the freezing point of water sample. That means the depression in freezing point we need to find. Right? So it is equals to TF naught, which is pure water 273, minus TF solution. Right? This quantity you need to find, and this is already given as 273. Okay, now what is this equal to? This is equals to IKFM. Now one thing here, we are given two components, AB. Okay, it has actually two components, AB and XY2. Two solutes are added here. So the overall depression in freezing point will be equal to the sum of the individual components, sum of the depression due to the individual components. Okay, some depression will be because of, some depression freezing point will be because of AB, and some depression will be because of XY2. And if you combine those, if you add both the depressions, you will get the final overall depression in freezing point. Okay, I hope you get the idea. Yeah, Vikram, the thing is, if you are weak in calculation, do approximation. I'll try to show you in some questions. So sometimes even you can't do the exact calculation, so you take a rough idea. Instead of, let's say, if written 78, you write 80 and then you do the calculation, right? So it becomes much easier if you do approximation. You'll get close answer, but it have a risk. For example, here you'll have to calculate it correctly because here the options are very close knitted. See, 264, 265, 280, 281, right? So here you need to do proper calculation. But for most of the questions in KCET, they don't want you 60 minutes, 60 questions, right? So the level of calculation won't be that tough. You can do approximation and solve it. Your answer will be correct only. 9th question, excluding calculation. I'll answer this first. How to know where to apply Van 't Hoff factor. Where it is clearly given, where they are talking about ionization, where they are talking about association, dimerization, these things will be given in the question only. Here it's given ionization. That means dissociation is happening. You need to apply Van 't Hoff factor. For example, in the last question, last question, dimerization was given. So that means association was happening. Here dissociation is happening. So you can apply the formula by reading the question. You know where to apply it. Okay. Always read the question twice also. Okay, let's see. 5.85%. Okay, let's calculate for AB first. For AB, let's calculate the Van 't Hoff factor first. Okay. In case of dissociation, Van 't Hoff factor is equal to, actually not Van 't Hoff factor, this alpha is equals to I minus 1 upon N minus 1. Yes. Degree of dissociation. Degree of dissociation or degree of ionization here, this is degree of dissociation. In equilibrium also it's same. It is equals to I minus 1 upon n minus 1 in case of when dissociation is happening. So some of you asked out in the last question how I solved it. I'll explain it after I finish this question. Okay. Okay, now let's see. This is the formula that we'll use for both cases, as in both cases dissociation is happening. Let's talk about AB first. The alpha is 0. How much? 80%. The alpha is 0.8. Vantov factor we need to calculate, right? And number of dissociated molecules. How many number of dissociated molecules? If AB is there, it will dissociate as A positive, let's say, and B negative, let's say. So that means there are 2. How many molecules are there? 2. 1 second. Okay, so how many molecules are here? 2 minus 1. I hope it is clear. I will come out to be 1.8. I will comes out to be 1.8 for AB. That is for AB. Okay, now let's talk about XY2. I need that number. Okay, I'll just do here. XY2. For XY2, let's calculate the Vantov factor. Can I name it 1? I'll say this is I1. I1 is 1.8. Okay, and for XY2, I will use I2. Okay, so then alpha will be equal to I2 minus 1 upon n minus 1. Alpha is how much? 60%. The dissociation is 60%. So it is 0.6 equals to I2. I need to figure out I2 minus 1 upon, for XY2, how many molecules are there? How many atoms we will get when it dissociates? X, let's say X positive and 2Y negative. That means 3 are there. N is equals to 3, right? Minus 1. If I calculate it, how much value? 2, 1.2, 2.2. I2 will comes out to be 2.2. Okay. That is there. I1 I figured out, I2 I figured out. Clear? Now what I need to do? I need to substitute all the values in the equation. What is the equation? Okay, I'll just erase here this equation. I1 KF M1, I2 KF M2. This depression freezing point is coming from AB and this one is coming from XY2. I hope it is clear. I know KF is same, right? KF is already given for water. So I can just write it as KF I1 M1 plus I2 M2. Okay. I1 is how much? 1.8 times. Molality will be how much? Now here the question comes. 5.85% weight by weight. That means 5.85 gram is dissolved in 100 gram. 100. Yes, 5.85 gram is dissolved in 100 gram of solvent. In 100 gram of solvent, right? Weight by weight. Okay, so that will be 5.85. Number of moles will be 5.85 upon 58.5. That is the molecular mass given. Okay, number of moles upon amount. If 5.85 is the amount of solute, if 5.85 is the amount of solute, what will be the amount of solvent? It will be 100 minus 5.85. It will be 100 minus 5.85. 94.15. 94.15. Clear? That is the first part, I1 M1. Is it okay? Is it clear? Ma'am, all this calculation, is there a way to identify easily if possible? For these type of questions, for specifically physical chemistry we are talking, electrochemistry, solutions, these you can't predict. Okay, for some there is some tricks and tips, but here you have to do proper calculation only. But see, they simplified it. You just cancel it out, right? It's 1 by 10. Okay, then what do we have? Plus 2.2 times, again 9.5 by 95 times 1000 upon how much will be the amount of solvent left? That will be 100 minus 9.5, 5.1, 91.5, 9.5, yes, that will be around 90.5, 990, yeah, 90.5, yes. Kf is already given, so if you calculate this value, this will be a long calculation. I don't have enough space. This will comes out to be some value will come out, and your final answer will be close to, it's not exact, but it will be close to 264.25. It's like 264.9 something. I calculated it, it came out to be 264.9 something, right? But you see, I know you can go to 265 also, because the answer is 265.4.9, but always take the lesser one when you're doing the approximation thing. Okay, yeah, you did it in 43.13 seconds, Prajwal. Yeah, that's actually really impressive. It's a lot of calculation. How can we do it in 1 minute? So yeah, that's what I'm saying. Some questions are calculative, right? They will take some time, but some questions are easy. For example, that intermolecular hydrogen bond we did, the first question we did, you will save some time in there, right? So you save some time there and you apply that time, use that time for solving these questions. I hope it is clear. Not in 1 second. So yeah, all questions are not equal, not in every calculation, or not in all the questions we will be doing these calculations, right? I know it is, yeah, you cannot guess, but yeah, you have no, don't guess actually, that's not a nice thing. Solve the question. This question, see, the calculations will be simpler one, don't worry. Yeah, 9th question, sorry. 9th question, hold on a second, this is the 9th question, I think. Yep, so we are talking about solute X which dimerizes in water to the extent of 80%. Okay, so solute X dimerizes. Here the word dimerization is given. That means Van 't Hoff factor we are going to use Van 't Hoff factor. Okay, extent of 80%. That means the association factor is also given, which is 0.8, 80%. 2.5 gram of X is added in 100 gram of water. It increases the boiling point. That means elevation in boiling point is given. And how much is that? Del TF, del TB, actually it is 0.3 degrees Celsius. The molar mass we need to figure out. So we know this expression, del TB will be equal to I KB M. Clear? I is Van 't Hoff factor. Now here, as dimerization is happening, that means the Van 't Hoff factor for association is going to use. We are going to use the Van 't Hoff factor for association. And how much that will be? You will calculate it using this formula. 1 minus 1 minus 1 by n times alpha. N is the number of associated molecules. Alpha is the degree of association. Alpha is the degree of association. And you calculate the Van 't Hoff factor. You put the value here, I. KB is already given. Del TB is already given, 0.3 degrees Celsius. M is the molality. Okay. M is the molality. So molality, in that case, you put all the values actually. Molality is number of moles of solute, which is 2.5 by M times 1000 by 100 gram of water, right? Only one thing is unknown, M. every other value is known, you substitute there and you calculate for m. It comes out to be 26. It's a fairly easy calculation. I hope it is clear now, right? You read the question first, what the question asks, right? If colligative property is there, and you see the word association, dimerization, dissociation, ionization, you use Van 't Hoff factor also. You don't use the simple equations, you use the equation where Van 't Hoff factor is added. Okay? I hope it is clear now. Why not dissociation? So in this case, dissociation we didn't use because the word dimerization is written. You know dimers, right? When two molecules combine and they form a dimer, like that carboxylic acid dimer that's there in solution chapter, right? Yes, so the word is written here already. The word is written dimerization, and like in this question, the word was ionization. That means we are talking about dissociation here. Ionization, dissociation. Okay, if you have any problem, you can just write it somewhere. I'll erase it afterwards. If ionization is written, it means dissociation. The formula for dissociation you need to use. If dimerization is written, that means the formula for association you need to use. Okay, now let's solve this question. If 3 gram of glucose is dissolved in 60 gram of water, if 3 gram of glucose is dissolved in 60 grams of water at 15 degrees Celsius, the osmotic pressure of the solution is, here no ionization, no dissociation is there, right? No ionization, no dimerization, nothing, right? So you'll use a simple equation. For calculating the osmotic pressure, we know pi is equals to CRT. C is concentration. C is concentration. It can be molality, it can be molarity, right? Any concentration. The data that is given, C depends on that. Okay, if the data for molality is given, you calculate molality. If the data for molarity is given, you calculate molarity. Here the data for molality is given, I think. So we'll calculate molality in this case. Clear? Okay, now let's solve this question first. 3 gram of glucose is dissolved. So 3 gram of glucose, number of moles will be 3 by 180. Number of moles of glucose dissolved in 60 gram of water. 60 gram of water. This is the molality. This is the molality. R is in, the answer is given in atmosphere. So in atmosphere, its value is 0.082 liter atmospheric. Mole inverse, Kelvin inverse. Clear? You don't need to remember it. Maybe you can, but this will be provided in your question only. For most of the questions, they provide this value. So you substitute this value 0.082 times 15 degrees Celsius. The data should be in Kelvin. As it is 15 degrees Celsius, the data should be in Kelvin. Okay, so you convert that 15 degrees Celsius into Kelvin, which comes out to be 288 Kelvin. 288 Kelvin. Okay, so you just put that value here also, 288 Kelvin. Okay, if you calculate it, what will be the answer? If you calculate it, tell me the answer. So if I just calculate it, 20, okay, I think its answer was 0. This is your answer. Option A. Give me a minute. Pen. Okay. Hello. Hello. Okay, so for this question, the answer is 6.57 if you calculate it. Okay. Pi equals to CRT, C we calculated in terms of molality, R is 0.082 and temperature is 288 Kelvin. Why in this we have multiple with, so Kani, so in this case we multiplied it with 0.082 because the answer is given in ATM, atmospheric. All the values are given in atmospheric, so you use the value which is in atmospheric. You use the value that is in atmospheric. Yeah, I'm back to. Yeah, we need it at the moment. Yes, you see the answers and that's how you use it. Normally it's given in, provided in the solution only, so question only, you don't need to worry that part. Okay, one of you was asking last question, 10th question. Yeah, it's a little tricky, right? But don't worry. Let's say we have this solution, water solution here. In this water solution, we added AB. We added a compound AB, right? And we also added a compound XY2. When you added both of these compound, due to these compound, what is this? Firstly, these compounds are non-volatile. Okay, if you add those compounds, there will be a depression in freezing point. There will be a depression in freezing point of water, right? How much will be the depression? The depression caused by this AB and depression caused by XY2. So what I did, I just added these individual depressions, and that will give me the overall idea of how much depression in freezing point has happened. Clear? Okay, for those, it's a little more calculative, I know, for your taste and for also KCET level, right? But it is a previous year question. You see, it came in 2023. So you calculated first thing, it's given here that it is ionized. AB and XY2 both are ionized. As I told you, ionization means dissociation. So we will use Van 't Hoff factor. How will we calculate Van 't Hoff factor? Using this formula for dissociation or for ionization. Clear? Using this formula, you calculated the Van 't Hoff factor. You substituted the values here. Okay. Molality may be a little of a doubt. So molality is the number of moles of solute present in 1 kilogram of solvent, right? Present in 1 kilogram of solvent. Now here the amount is given 5.85% weight by weight. That means 5.85 gram is present in 100 gram of solution. 5.85 gram of solute is present in 100 gram of solution. So that means how much will be the amount of solvent? 100 minus 5.85. Clear? 100 minus 5.85, and that's how you calculated the molalities. Clear? Now the question doesn't end here only. This value will come out to be something. Clear? You need to find the change. You need to find the freezing point of the water sample. How much will be the freezing point of water sample? Pure water is freezes at 273 Kelvin. The freezing point of this water sample will be, there will be a depression. That means 273 minus TFS, which is the water sample, the freezing point of the water sample. That is equals to this whole calculation. Clear? After that, what will you do? 273 minus that number, the answer will comes out to be 264.9 something. So we take it 264.25. Okay, I hope the one who was asking for question 10, this doubt is clear. But for your own sake, sit down and answer it yourself once. Okay, once this class is over, do it on your own. I know it's a little lengthy calculation, but it's just lengthy. Every data is given here. Okay. I don't want to take the risk of seeing the answer key, but I think I can score near to 94. Hi everyone. Okay. Chemistry is not tough to understand. It just, you need a strong basic in chemistry, and that basic is from your PU1. If you studied your PU1 nicely, you will understand your PU2 very easily, because PU1 is much tougher. Why? Because you are switching from 10th to 11th in that case, right? The level is a little higher for your sake. But if you did PU1 nicely, don't worry about your, you won't have to worry about this. Okay, but no worry, I'm here to solve the questions with you. I'm here with you. Any doubt you have, ask me. Any concept you don't understand, I'll answer it. Okay. Which of the following pair of solution is isotonic? Now, isotonic solutions are those solutions which have same osmotic pressure. Isotonic solutions are those solutions which have same osmotic pressure. Then we have hypotonic and we have hypertonic also. So hypotonic solutions are those which have lower solute concentrations, lower concentration. So what happens normally when you put a hypotonic solution, what happens? The cell swells. Okay, swelling happens, right? For example, have you tried, if you soak those raisins in milk or even in water, they soaked raisins, they are much thicker, right? The dried raisin is small and the soaked raisin is plump and thick. Okay, hypertonic solutions are those solutions which have high concentration, high solute concentration. So what happens when they have high solute concentration? The excess concentration. So what happens in this case? They shrink. That means the concentration, how will I explain it? What happens? Actually, yeah, when our feet get swelling, sometimes when you are standing on your feet for too long or you're doing something, your feet get swelled, right? And what do? You put your feet in salt solution, warm water having salt, right? What happens? The your swelling goes away, right? The pain also goes away, but the swelling also goes away. That is an example of hypertonic solution. That salt solution is hypertonic solution, right? Okay, so what is the answer for this one? Let's see. Isotonic means same osmotic pressure. Same osmotic pressure means pi 1 will be equal to, let's say, pi 2. What is pi 1? C1 RT C2 RT. Okay. Okay, let's see. Here, now see. All of these are ions. All of these are ions. All of these are strong electrolytes, or you can say these will dissociate. Okay, what will be the answer for this? You guys are not answering. Okay. Now see, all these components are there, all these compounds are there, they will dissociate. We know why, because they all are ionic in nature. They all are ionic in nature. So there will be Van 't Hoff factor. There will be Van 't Hoff factor that we need to include. The concentration is same. The concentration is same. No, it's not same. It's different. Okay. Let's see. So for say isotonic solution means same osmotic pressure. That means pi 1 equals to pi 2. I1 C1 RT will be equal to I2 C2 RT. RT gets cancelled. So we just solve for all of these, or do we have an idea? Let's start from the first one. Al2SO4 thrice. We calculated 2Al4, 3SO4, 2 negative, 2Al3 positive, 2 plus 3 means 5. The I is 5. For BaCl2 it's 3. For CaCl2 it's also 3. For this it is 5, 3. Okay, I'll just calculate it right straight. For first one, I'm calculating 0.5 times 0.001. 0.005, right? The right hand side should also be equal. 0.01 times 3. It is 0.03. So obviously this is not isotonic. As you see, the pressure, this term is not equal. I1 C1 should be equal to I2 C2. I1 C1 should be equal to I2 C2. Okay. Next question, next option. CaCl2 and this one, I can just look at it and answer, right? If I multiply 3 with this, 0.003, and here it will come out to be 0.005. Obviously incorrect. Here also 0.03 and 0.003. 0.03 and 0.003. So obviously the pressure is not equal for these also. Last option. This is 0.03 and this is also 0.03. Why? If you multiply it by 2, NaCl gives I equals to 2. The Van 't Hoff factor for NaCl is 2. So if you multiply 0.015 times 2, that will be 0.03. This is correct, as the osmotic pressure is equal for this. So the correct answer is option D. How many of you answered option D? Let me see. Okay, one answered A. Okay. D. Yes, correct. Next question. Which of the following aqueous solution has the highest freezing point? Highest freezing point. Highest freezing point. 4, 2. The concentration is same. Let me rephrase it. Highest depression in freezing point. Highest depression in freezing point. Which will show the highest depression in freezing point. Okay, so the highest depression in freezing point will be shown. All of these have same concentration, right? So we'll calculate the amount of solute, which will have the largest amount of solute. How many here? Again, Van 't Hoff factor we are calculating. Is it clear? For Al2SO4 thrice we have 5. 2Al3 positive, 3SO4, 2 negative. For AlCl3 we have 4. Al3 positive and 3Cl negative. Okay. For BaCl2, again Ba2 positive and 2Cl negative. For NH4Cl, we have NH4 positive and Cl negative. That means 2. So the highest Van 't Hoff factor is for highest amount of solute is for Al2SO4 thrice. 0.1 molar Al2SO4 thrice. So the depression, the highest depression will be for this only. The highest depression will be for this only. Yes, D. Why D? Highest depression freezing point. I rephrase the question a little bit. Okay. Yes, if we are talking about highest freezing point, that means the freezing point is high. Lowest depression freezing point, right? Highest freezing point means lowest depression freezing point. I am talking about highest depression freezing point will be for first option. Clear? Okay, my bad, I rephrased the question and you didn't see it. Yes, if it is highest freezing point, it's D, but if it's saying highest depression freezing point, it's A. Yeah, if it is only highest freezing point, yes. In case of highest freezing point, we are looking for what? The value of, there is not great depression, right? So the depression should not be high. So in that case, the opposite we are looking for, which is the lowest depression freezing point we are looking for. Okay. Correct, Kalyani. 13, if it is gaseous solution. Gaseous solution. In gases also, freezing point, if we are talking about freezing point, so then we are talking about liquid to gas, right? Freezing is calculated for those only, liquid to gas. Okay, yeah, so in case of gas, it will be a different quantity. Relative lowering of vapor pressure we'll talk about. But freezing point we talk about, or in boiling point also we'll talk about. But in freezing point we won't talk about gas. Okay? Okay. Next question. 200 ml of an aqueous solution of protein contains 1.26 gram of solute. The osmotic pressure of solution is found to be this much. You need to find the molar mass. It's very easy. How? Because we know osmotic pressure is equals to concentration RT. See, it's already given. The R value they want you to use, it's already given. Okay. Pressure is also given. Osmotic pressure is 2.57 times 10 raised to power minus 3. Okay, the concentration we need to figure it out. R is already given 0.083 liter bar mole inverse Kelvin inverse. Temperature is already given 300 Kelvin. Okay, concentration, let's put all the data. 2.5 times 10 raised to power minus 3 equals to concentration. What data is given? 200 ml of an aqueous solution of protein contains 1.26 gram of solute. So 1.26 gram of solute is dissolved in 200 ml of water. Okay. So this is molality. In this case, this is molality because the data for molality is given. Clear? Okay. Next, multiply by 0.083, which is R, and temperature is 300 Kelvin. This is unknown. Only this quantity is unknown. All the other data is given to us. So you can just calculate it. Okay. If we calculate it, this one is an easy calculation, right? You guys can do it. Because it's protein. Boiling point, yeah, clear. Okay, what is the answer for this one? Okay, so boiling point, the osmotic pressure is given. Molar mass of the protein will be 61,038 gram per mole. How many of you got answer option D? How many of you got option D? A, C. If only different molar concentration given, then instead of I value, if only different molar concentration is given, then I value. So it depends on what kind of component we are dealing with. In case of molar concentration, is directly proportional, no? The depression delta TF equals to I KB KFM. The concentration is directly proportional. So in that case, the highest concentration, if the I value is same for all the solutes, for all the solutions, the I value is same, then you look for the concentration. Highest concentration will show the highest depression freezing point or highest elevation in boiling point. Clear? The relation is straightforward. Okay, D. Yes, if you calculate it, if one of you calculated it, the answer would have come out to be 61,038 gram per mole. Okay, next question. Equimolar aqueous solution of NaCl and BaCl2 are prepared if the freezing point of NaCl is -2 degrees Celsius. The freezing point of BaCl2 solution is NaCl solution's boiling freezing point is -2 degrees Celsius. Okay, now see. This is how you calculate the depression freezing point, right? Here Kf value is same, concentration is also same, equimolar, and same water solution we are using, that means Kf value is also same. So can I just write here as del Tf is directly proportional to I, right? And the del Tf is directly proportional to I, because I am given two I values and I need to find one del Tf value. I'll explain. So that means if I remove it, if I can also write it like this. Is it clear? Right? From this, I can write it like this. Basic maths. B, yes, the option. If I put the data here, del Tf, the freezing point is -2 degrees Celsius. The freezing point is -2 degrees Celsius. It will be -2. Hold on a second. This is 2, this is 3, and this is we need to find. Yep, the answer will be -3. I thought so. Implies del Tf clear? Everyone, is it clear? B, yes, B. Directly proportional relation is there, okay, and then we know this value is -2, this value we need to find. The Van 't Hoff factor for NaCl is 2, for BaCl2 it's 3, so that means if we just substituted all the values and calculated it, the answer came out to be -3 degrees Celsius. Option B. Clear? Okay, good. Now my dear students, I think we are on to let me just, it's not PYQs exactly, I have mixed questions also. Okay, we'll start electrochemistry. Solution we have done. We have practiced all kind of questions from solution chapter. Zoom class so that we can interact with you. Wow. When is organic chemistry lecture? So I think I planned it on our after like second, third live we'll be having organic. I think it's the third live. Yep. For me, I'm covering the high priority topics first. So I am trying to cover all the important, the high weightage topics that are going to come in your KCET. Solution electrochemistry are very important. Okay, they carry high weightage. So don't skip these lives. Okay, you have time. You can study. You can revise now. Okay. Let's start electrochemistry. Are you ready? First question. Same amount of electric current is passed through solutions of silver nitrate and AgCl. If 1.08 gram of silver is obtained in the first case, the amount of hydrogen liberated at STP in the second case is. So it's not a simple question. Well, Sky Moon, it depends on your consistency also, because if you see our lectures and you just see them and after that you don't revise, you don't solve questions, nothing will happen. Okay, sorry to disappoint you, but yeah, if you don't revise, if you don't stay consistent, if you don't solve questions, okay, nothing can happen. You need to, if the lectures are really good, all teachers are putting a lot of hard work for you all. These all questions are of very utter importance for you all. Okay, and if you take the lectures, watch the master stroke, okay, and then you solve questions and revise and solve questions every day. Okay, and trust me, you are going to score good rank, don't worry. Okay, yes, okay. So for this question, option B, nope, Madhavi, option B is not the correct answer. Okay, let's see. Amount of, read the question twice. Okay, always read the question twice. Same amount of electric current. We are given two solutions. One is of AgNO3, the other one is of HCl, right? In one case, silver is liberated, and in the other case, hydrogen is liberated. Okay, now both gases will be liberated at cathode. Yeah. Yes, both gases will be liberated at cathode. Now what is happening here actually, that which law is applying here? Faraday's second law. Which law? Faraday's second law. The law is Faraday's second law. You don't need the statement, so I'm just giving you a rough idea. So according to Faraday's second law, if you have two different solutions and two different electrolyte solutions, and if equal amount of charge, equal quantity of charge is passed for equal amount of time, the weight deposited at respective electrodes, anode, cathode, the weight deposited will be directly proportional to the equivalent weight, or electrochemical equivalent, somebody say, but I'll use equivalent weight. That's a much simpler statement. That means if we are given two electrolytes and in one silver is depositing and in the other hydrogen is depositing on the same electrode, cathode only, okay, the electrode should be same. Okay, and the weight will be directly proportional to the equivalent weight. Clear? I hope it is clear till here. Okay, this is Faraday's second law. Faraday's first law. What is Faraday's first law? Mass deposited will be directly proportional to the amount of charge, right? It is ZIT. Mass deposited, in case of electrolysis, the mass deposited is directly proportional to the amount of quantity of charge passed through the solution. Okay, you don't understand what? Okay, it's very easy, solve it. What? Yeah, any doubt you have, tell me some. Okay, answer this question. What will be the answer? And whatever doubt you have and what did you not understand? C. Yes, C is the correct answer. Correct. Okay, let's see. So W1, let's say, is silver and W2 is hydrogen. Equivalent weight of silver and equivalent weight of hydrogen. Okay, the answer is a little different. Okay, that's why you guys are having problems. This much amount of silver is deposited, 1.08 gram, and the amount of hydrogen we don't know. We need to figure that out. We need to calculate it. Okay, equivalent weight of silver is 108 gram. The valency is 1. For silver, the valency is 1. So it will be 108 only. Okay, for hydrogen, it's almost 1 only, right? For hydrogen also, it's almost 1. So if we calculate it, the value will come out to be 0.108, 1.08. Clear? Yes, the value will come out to be 0.01 actually. Yes, the amount of gram. The amount of hydrogen deposited is 0.01 gram. Okay, now see, you see any options like this? No, right? So that means you need to convert this value. That means you need to convert this value in something else, in volume probably, because centimeter cube is written. So how will you convert it? At STP, at standard temperature and pressure, 1 mole of hydrogen, 1 mole of hydrogen, which is around what? 2 grams. 2 gram of hydrogen has a volume of 22.4 liter. At STP, 1 mole of hydrogen. How much is the weight of 1 mole of hydrogen? 2 gram, right? So 2 gram of hydrogen has a volume of 22.4 liter. If I convert this liter in centimeter cube, it will be 22,400 centimeter cube. 22,400 centimeter cube. Okay, now something is making sense, right? 2 gram equals to 22,400 centimeter cube, and the amount deposited is 0.01 gram. How much volume will that be? 0.01 gram will be equal to 22400 by 2 times 0.01. That will be 11. Clear? So the correct answer is option C. Yes. Yes, option A. No, it's not A. It's not A. See, 2 is there. You forgot the 2. 1 mole of hydrogen has 2 gram. The weight is 2 gram for 1 mole of hydrogen. Okay. This is the extra calculation you need to do. Okay, this one was easy if you know Faraday's second law. This is Faraday's first law. Okay. Some questions might come about Z, electrochemical equivalent. So this is equals to actually equivalent weight by F, or you can write as equivalent weight by F, or atomic weight by N factor. N factor times F. Okay, this is also important. Sometimes some questions will get from this Z only, the electrochemical equivalent. Okay, 112 centimeter cube. Correct, Sky Moon. Yes, C. Yes, C. Okay, next question. Aluminum displaces hydrogen from dilute HCl, whereas silver does not. The EMF is given. You need to find the electrode potential of aluminum. Okay, now one more thing here. How can you find it out? How will you decide which is anode, which is cathode? How will you decide which is anode, which is cathode? Firstly, tell me what happens at anode, oxidation or reduction? Sorry, what happens at anode? And what happens at cathode? So my dear students, at anode oxidation happens always, and at cathode reduction happens. This you should have a clear idea. I think it's very basic. At anode oxidation happens, at cathode reduction happens. Now how will we decide which will be anode and which will be cathode? So one other thing is there. We know this formula, right? So we know that aluminum is displacing hydrogen from dilute HCl. That means aluminum is more reactive than silver, because silver is not able to do that. That means aluminum is more reactive than silver. So when we talk about reactivity in case of chemistry, what do we talk about? We talk about electron donation actually. Okay, so that means that aluminum can donate its electron more easily. That aluminum has the capacity to donate its electrons more easily than silver. Correct? Just write it somewhere. If we are talking about highly reactive, reactive means they are able to donate their electrons. So aluminum is more easily able to donate its electrons. That means what is happening here? Loss of electrons. So aluminum is getting what? Oxidized. Aluminum is getting what? Oxidized. Oxidized, right? So that means it will work as what? It will be acting as anode. That means it will be acting as anode. Anode and cathode. So simple difference, just for your exam, only one thing you need to know, that anode is the place, anode is the electrode where oxidation happens. Oxidation means loss of electrons, addition of hydrogen, addition of oxygen, loss of hydrogen, and yeah, these three things are more than enough. And increase in oxidation number, yes, 4. So you have loss of electrons, gain of oxygen, loss of hydrogen, and increase in oxidation number. If these 4 things are there, you call that oxidation, right? And it happens at anode. You just remember it, oxidation O, and anode has an O at the beginning only. Okay, then at cathode what happens? Reduction happens. What is reduction? Gain of hydrogen, gain of electrons, loss of oxygen, and again decrease in oxidation number. There is a decrease in oxidation number, that is called reduction, and it happens at cathode. Simple, that's all. Okay, now see, we need to, okay, now we know that anode is what? I'll write here. That means anode is aluminum and cathode is silver. I got this because this statement is given. Aluminum is more reactive than silver. As aluminum is more reactive than silver, that means aluminum is more prone to oxidation. It willingly wants to lose its electron. That means it's getting oxidized. If it is getting oxidized, that means it will act as anode and silver will act as cathode. Okay. Now, how do you calculate the reduction potential of this cell? That will be equal to E naught cathode, reduction potential at cathode, minus the reduction potential at anode. Clear? The reduction potential is given actually. It is 2.46. Okay. Cathode is silver. For silver it's also given 0.8. Minus, for aluminum we need to figure out. This we need to know. So what will I do? I'll just take it on that side, left hand side. It will be equal to 0.8 minus 2.46. That will be minus 1.66 volt. How many of you answered D? D, yes. Girish, it's not A, it's D. Yes, Kaimun, correct. Okay. I hope you got the answer. Minus 1.66. How do we get it? Like this. Because before that we didn't know which will be anode, which will be cathode. Okay, we need to figure that out first. Only then you can substitute in this formula, right? Yes, minus 1.66. D, correct. Galvanic cell lone means left oxidation. Yeah, that's also left. Anode is always written on the left side, and left side always oxidation happens. Cathode is represented on the right side, so at right side reduction happens. Right reduction, left oxidation. Yes, correct. Okay, next question. Within 1 minute, if you can answer it. If you can answer it within 1 minute, just yes, correct. Okay, see, the hydrogen electrode is dipped in solution of pH 3 at 25 degrees Celsius. The potential you need to figure out. Okay. pH 3. This is the reaction happening. This is the reaction happening in case of this hydrogen electrode, which is dipped in a solution having a pH 3. Okay, so what do we know? How to calculate the E cell? E cell equals to E naught cell, the standard reduction potential, standard potential of the cell, minus 0.059 by N log of product concentration upon reactant concentration. Here the product is hydrogen. Product is hydrogen, right? So we take this one, actually the hydrogen gas. The activity, if it's not specified here, we take it 1 only if it's not given here. Okay, so here it will come, right? For H positive the data is given. For H positive, no, data is also not given for that. Okay, this is 1. Unless specified, we take it 1 atmosphere only. Okay, next, E naught cell for hydrogen electrode, it is 0. We already know that E naught cell for hydrogen electrode is 0. Okay, so that means E cell will be equal to minus 0.059, and how many electrons are involved? 1 electron, log of, again I told you the for hydrogen gas, unless specified, the concentration is taken 1. You can write as 1 raised to power 1 by 2 also, because it is 1 by 2 here, the stoichiometry, 1 by H positive. We also know one thing, that pH is equals to negative logarithm of H positive. Something is here, right? Negative logarithm of H positive is here. So what do? Solve it. It will be minus 0.059 times 3. Clear? Basic logarithm, I solved it before because I know this is 0 and minus plus, but I want the negative, so I substituted minus 3. Okay? What will be the answer? It will be 0.177 volt, minus 0.177 volt. Minus 0.177 volt. The answer is D. Correct. Yes, everyone is answering D. Yes. Okay, I hope it is clear. Let's move on to the next question. Assertion says, in a cell with E naught cell less than 0, the cell reaction is always spontaneous. Okay, when you are answering assertion reason question, just a tip. After reading the assertion, add a because and then say your reason. After reading the assertion, add because at the end and then say your reason. If it makes sense, if the reason is explaining the assertion, then option A. Clear? Unless if it's not, then the other option you look for. Now see, in a cell, spontaneity we are talking about. We are talking about spontaneity. For spontaneous reactions, for spontaneous cell reactions, 2 criteria you remember. Delta E or E cell. E cell. I can write E cell actually. E cell should be positive, always positive. That means it should always be greater than 0. It should always be greater than 0. First. And second is delta G. Change in Gibbs free energy should be less than 0. It should always be negative. Clear? The E cell, the cell potential should be positive and the Gibbs free energy should always be negative. These 2 criteria we need. Okay. Now see, assertion is saying in a cell where the E naught cell is less than 0, the cell reaction is always spontaneous. That's incorrect. That is incorrect because the E cell should always be greater than 0. Okay. This is incorrect. When a spontaneous reaction occurs, Gibbs free energy decreases. Yes, it decreases. It becomes negative. More negative this value is, more spontaneous the reaction is. Spontaneous means happens on its own. Little push you give, but it happens on its own, right? For example, when you are coming, when I'm throwing, like let's say if I am putting water like this, the water is coming on its own. I'm just holding it there, but it's coming on its own, right? I don't have to bubble on it or blow on it so that it comes out, right? So that's a spontaneous process, right? Yes, option D. So assertion is not true, but the reason is true. That means the correct answer is option D. Next question. State which of the following is the strongest oxidizing agent. Oxidizing agent means, what does it have in terms of oxidizing agent? Oxidizing agent means it oxidizes others and reduces itself, right? Oxidizes others and reduces itself, right? That is the only criteria we have. Okay. Now remember one more thing, when we are talking about oxidizing agent, okay, we talk about reduction potential. Higher the reduction potential, the better the oxidizing agent. Higher the reduction potential, the better the oxidizing agent. Okay, stronger the oxidizing agent. Clear? And lower the reduction potential or more negative the reduction potential, stronger will be the reducing agent. These two things, they are universal. Just write it down somewhere. It's a short trick. I remember it like this. Oxidizing, the higher the reduction potential, better will be the oxidizing agent, stronger will be the oxidizing agent. Lower the reduction potential, stronger will be the reducing agent. Okay. So some of you answered D, some of you answered A, B. How B? Okay, let's see. Which of the following has the highest reduction potential? These all are reduction potentials. Check clearly. These all are reduction potentials. Right? So all these reduction potential, which among these has the highest reduction potential? This one, right? 1.52 volt. That is the highest reduction potential. Clear? So highest reduction potential is for MnO4 negative. That means the strongest oxidizing agent will be MnO4 negative. If you want to write in a sequence, we can write. Okay. So weakest will be this Br2. Weakest will be BrO3 negative, weakest oxidizing agent. This is the weakest oxidizing agent and this is the strongest oxidizing agent. Clear? Yes. A. Correct. So everyone answered A. Correct. Next question. The electrode potentials are given. Hey, this is actually, no, this is a different one. Okay, the most reactive metal which displaces other metals from their salt solution is. All the reduction potentials are given. You see, all the reduction potentials are given. For silver, for copper, for cobalt, for zinc also, right? And I told you some questions before that the more reactive the element, more easily will it get oxidized. More reactive the element, more easily will it get oxidized. So that means what we are looking for? Low. The reduction potential should be lower, easily oxidized, right? Oxidized means oxidation potential should be high, but reduction potential should be low. Clear? Which among these has the lowest reduction potential? Okay. Because in terms of reactivity, as I am explaining again, in terms of reactivity, we talk about electron donation, right? Losing electrons. The more easily a compound or atom loses electrons, the more reactive they are. Okay. So if they are losing electrons, that means oxidation. Their oxidation potential should be high, right? So the opposite of that is high oxidation potential, that means low reduction potential. And in this case, the answer is D, which is zinc, because zinc has the lowest reduction potential. D. Yes, the correct answer is D. Okay, next question.
Hello.
Hello, am I audible? Correct? Okay. Yeah. Thank you. Am I audible to you all? Hello? I don't know much about KCET. Please, can you suggest me what and how should I do? Okay, hold on a second. Something open there. Okay. Fatima, yes, so many of you are helping Fatima. So Fatima, if you started right now, you still have time, but one thing is there, your basics should be clear. From your PU1, your basics should be clear. Not remembering, I'm saying, because yeah, from PU1 also you get around 17 to 20 marks, okay? But major portion is coming from your PU2, but to understand that PU2, you should have a knowledge of PU1. So I would say, start by revising PU1 and PU2 both. Focus on PU2 more, question solving from PU2. From PU1, strong your, work on your basics. Okay. No, it's very easy. Okay, see this question, if you guys can tell me the answer for this question. This is a very good question actually. Yes, even it took me 2 tries to solve it. Like, it's a not difficult one, I'd say little lengthy maybe. Okay, now see. Undergoes simultaneous oxidation. This is the overall reaction. We need to find the E0 for this reaction. This is our reaction. I am going to simplify it a bit. Okay. This reaction, we need to find the cell potential, the E cell, overall cell potential for this reaction. Okay, so I can just write it like this: Cu positive plus Cu positive here. What is happening here? Cu plus, one Cu plus is getting converted into Cu2 plus. That means oxidation state is increasing. Oxidation state is increasing. This is oxidation. Okay. What about here? From +1 it is going to 0. +1 to 0. Decrease in oxidation state. This is reduction. This is reduction. This is oxidation and this is reduction. Till here we know the story. Okay, so then how will we calculate the cell potential? That will be E0 cathode minus E0 anode. Oxidation means this is the anode. Reduction means this is the cathode. Your E cell will be equal to E0 cell will be equal to E0 cathode. What is cathode? Cathode is copper to positive to copper. Copper positive to copper. Minus E0 anode. What is the anode here? This is the anode. Copper to positive to copper positive. Now look at the data what we have. We have this copper to copper positive. This value we have. But this value, do you see that value anywhere? Cu2 plus to Cu. The other value is given, but this value is not there. We need this value. So firstly, we'll calculate this value. Copper plus to copper, copper plus to copper. Okay, that reduction potential we'll calculate first. How do we calculate it? So I'll write the reaction. Cu plus okay, then these two reactions, okay, from these two reactions I can calculate this value. How? Okay, one more thing, electrode potential is not additive, so you can't just simply add or subtract like this. Okay, it's not additive. Okay, Gibbs free energy is additive, electrode potential is not additive, it's non-additive in nature. So you use different rules to figure out the electrode potential. If I combine these reactions, what will be the overall reaction? So for this is what I need to figure out, right? This is what I need. These are the same thing. The reduction potential for Cu plus Cu, right? The cathode in this case, I need that potential. How do I calculate it? C. I don't think its answer is C though. Okay, I'll calculate it first. It's not C, I think. Okay, so here this is equation 1 and this is equation 2 and this is equation 3. Using these, we calculate the electrode potential for this reaction. How do we calculate it? Now see, there is thing called Gibbs free energy, right? This Gibbs free energy is related to electrode potentials like this, NFE, right? Minus NFE, or if not is there, then NFE naught. Clear? Okay, so we will write this formula for all these three reactions. If we add 1 and 2, okay, 1 minute. It's a little confusing question. No, it's not actually. We just need to find the data. People blindly solve it. If you solve it blindly, you will get an answer from this only. Okay, that's not an issue. But that's actually an issue. The thing is, you need to figure out first what data we need. If this is the reaction happening, which is getting oxidized, which is getting reduced, you write that down simply, right? And then you calculate it for this one. This value you need to find. We are doing the calculation solely for this because this value we already know. This value we already know. We need to find this value only. So how do? We write two reactions, right? And because Gibbs free energy is additive, that means the delta G3, the overall reaction, this reaction's Gibbs free energy will be equal to the sum of the Gibbs free energy of the other two reactions, right? 1 plus 2, because what we did, we added these, right? Okay, so I'll just substitute the value minus N3 E3 equals to N1 E1 plus N2 E2. Okay, minus, it got cancelled. F, it got cancelled, right? All these three values are different. This I need to know. What is E3? This is E3. This is E3. Okay, now just let's write the values. E3 will be equal to what? N1. For first reaction, how many electrons are involved? 1 electron. Okay. And for this reaction, Cu plus to Cu2 plus. This is the electrode potential, 0.15. But see, the reaction is oxidation. This is the oxidation potential. So in this case, we reverse the value, minus 0.15. For this reaction, as it is an oxidation reaction, what we'll do, we'll reverse the reduction potential as minus 0.15. Okay, plus. For second reaction, the number of electrons involved are 2 and the cell potential is 0.34. If I calculate it, the answer will come out to be minus 0.15 and 0.68. Yeah, 3, 5, 0.53. Okay, yeah. So the electrode potential is 0.53. Now I have this value. Okay, I'll substitute it here. Okay. E naught cell will be equal to 0.53 minus this one is given Cu2 plus to Cu plus, which is 0.15. 0.38. Option A. D, C, D. Wait, I understood. Oh, you understood it now? Okay. A. Yes, the option is A. Yes, the option is A, correct. Because we know two things are here. You have electrode potential and Gibbs free energy. Electrode potential is non-additive in nature. You can't add it simply, okay? But Gibbs free energy is additive in nature, and we know the relation between Gibbs free energy and electrode potential. Okay. That's how you calculate it. Some questions are a little tricky. Okay, this was one of them. If you solved it using those values also, you will get an answer. You'll get an answer which is close to, which is in here only. Okay, but you need to calculate this part. For this part, we did all the calculation. The overall cell potential calculation was actually easy. This calculation was a little tricky because you need to write the equations and then you need to reverse it also here. This one also I must, yeah. But option A, can you explain, ma'am, one more time? Okay, I'll try. Okay. What is happening here actually, this is the overall reaction, 2 Cu positive giving Cu2 positive and Cu. Okay, I just expanded this equation. Instead of 2 Cu positive, I wrote Cu positive plus Cu positive, right? So 1 Cu positive is getting converted into Cu2 positive, that means it is undergoing oxidation. Cu positive is getting converted into Cu, that means this other one is undergoing reduction. I need to find the overall cell potential, that will be E naught cathode minus E naught anode. Oxidation means anode, reduction means cathode. So E naught cathode minus E naught anode. I am given the value of cathode only, anode only. I am not given the value of cathode. For this I need the calculation. So what did I do? I can't calculate it simply, right? What did I do then? I'll write these equations, okay? I have to find the overall cell potential for this Cu plus 2, Cu plus 2 Cu, right? Cu plus 2 Cu, this equation. So I just wrote it down. 1 Cu plus is getting converted into Cu2 plus electron. See, it's a hit and trial. I didn't get it the first time. I thought of writing the equation little differently, right? But in the end, I know if I write it like this, the answer will be like this. It's like hit and trial, right? You do division in polynomials and all. So this is one equation, and the second one, Cu2 plus, is adding these 2 electrons and getting converted into Cu. Because for these reactions, for these, the electrode potential is given. You see here and here, the electrode potential for these equations is given. Then you added, made the whole equation, right? And then we know delta G naught equals to minus NF E naught, right? So delta G for this cell, Gibbs free energy is additive. That means if you are adding these two cells, the Gibbs free energy for third cell will be the sum of the Gibbs free energy of first and second cell. They directly you add it. Okay, so we added it, and yes, N1E1 equals to N1E1 plus N2E2 equals to N3E3, right? I think I removed it. Yeah, it was here only. And from there you calculate the E3 value for this. If you figure this out, clear, you substitute it here, and that's how you get E naught cell. One more thing you need to remember, here I took minus 0.15. Why? Because the reaction is reversed here. This is oxidation, not reduction. This is oxidation. For these questions, we have to find these reactions, and if the data is not given, only if the data is not given. If data is given, if this data is already given, I would not have done this calculation. It's simple then. Use this formula. Okay. Sometimes once in a while they ask it. From electrochemistry, majority questions are like that only. Okay. Okay. Next question. For spontaneity, which is correct, I just told you delta G should be negative. E cell, delta E should be positive. Do we have that here? Positive. This is wrong. Okay, this is correct. Okay, let's check the other option. 0, 0. These are not correct. It should always be positive. So that means the correct answer is option B. Name anyone. What do you want me to name? Any session for NEET. Well, NEET. Start with your basics first. Start with your NCRTs, and then I can recommend you books actually. But apart from that, sessions you watch one shots, or if you have any course, you watch that. NEET is a long run to go, right? Because it's March. You will be having exam in July, right? June, July, something. Yeah. Okay. So for NEET, I'll get back to you. Don't worry. What's your name? Okay, what is your name? Key points for electrochemistry. Key points is, yeah, option B is the correct answer. Key points is practice questions every day. Yeah, for electrochemistry, you focus on equilibrium constant questions. focus on Nernst equation problems, and then you have those conductance, right? Formulas for conductance, cell constant, how is conductivity, molar conductivity, equivalent conductivity, that is also very important. And majorly questions were from these 3-4 topics only. Okay, Nernst equation, equilibrium constant, and then conductance terms, all the conductance terms that are there, formula based. Okay, and little question here and there for spontaneity and all. Some questions were from fuel cells, but they were asked long ago, 2015 something. Okay, so it's written in the description, I think, but I'll tell you all again. My name is Ekta. I'm your Ekta ma'am. Okay, and yes, so how is it going so far? Are you able to solve these questions? This is the reduction potential of the electrodes is in the order. Okay, let's not see here, it's getting a little confused. We know the reaction. What is happening here? Ag positive is getting reduced. Reduction is happening, right? Gain of electrons, reduction is happening. Ag positive is getting converted into Ag. Okay, now I'll write the E cell reaction equation, actually the electrode, how to calculate the cell potential for this particular cell. E cell will be equal to E naught cell minus, I'll just take it 0.059 by n, number of electrons, okay, log of. Hey, one of you was asking about calculation, right? So if in this equation, normally I am doing like this, but I take it, instead of 0.059, I take it 0.06. That's how you approximate and solve the questions. It doesn't matter. Okay, log of product concentration, Ag, which is solid, right? And activity of solids and liquids is normally taken 1 only. Why? Because they don't undergo much of a concentration change. Solids and liquids don't undergo much of a concentration change. If it's pure solid or if it's pure liquid, they will not get under any change, and that's why the activity we consider for them is 1. So here it is 1 for Ag. Okay, and right, this is the reactant, product by reactant. Product is solid, its activity is 1, then divided by reactant, which is Ag positive. N is 1 electron is involved. Okay, E naught cell is also given 0.80, clear, minus 0.06, N is 1, I am not putting the value here, log of 1 by Ag positive. Okay, I'll just solve the log. Minus 0.06 log 1 is 0, right? Minus or minus plus 0.80 plus 0.06 log of Ag positive. This is E cell. Can you see the relation now? That's all you need to do, nothing more than that. You see that concentration of silver is directly proportional to cell potential. If this value is high, this value will be high, this value will get added to 0.8. That means the electrode potential will be higher than this one, higher than the normal standard potential, right? How much high, that depends on this second part, this Ag positive. More the silver ion concentration, more will be your E cell, direct relation, right? Which has the highest ion concentration here? Let's see, 10 raised to power minus 4m, right? 10 raised to minus 2m, 1, minus 1. 10 raised to minus 1m, this is 10 raised to power minus 2m, this is 10 raised to power minus 3m. Now see, 4, minus 4, minus 1, minus 2, minus 3, which has the highest concentration? You need to write them in decreasing order of reduction potential. Decreasing order of reduction potential. Again, just to sum it, revise you all. Ag positive, higher the concentration of silver ion, higher will be the reduction, higher will be this reduction potential. Okay, okay. Now 10 raised to power minus 1, first will be B, highest will be for B. Which option is there? You already got your answer, A. Okay, after that 10 raised to power minus 1, 10 raised to power minus 2, which is C. After that 10 raised to the power minus 3, which is D, and the least will be for A. Why? Because it has the least concentration, 10 raised to the power minus 1, 0.0001. Okay? Yes, then the correct answer is option A, not B. It's option A. Correct. Fatima, it's not C. Option A. Okay. Next question. For this half cell, increasing the concentration of aluminum ion, the electrode potential is. Reaction is already given. You just write the E cell equation. E cell will be equal to E naught cell minus 0.06 by N. N is how much? 3 electrons are involved. I'll write 3 log of Ag, aluminum. This is solid, right? And the activity of solid is 1 by Al3 positive. Okay. Again, same thing we'll calculate. E naught cell plus 0.02 log of aluminum 3 plus. Okay, here also the relation is same. If we increase the concentration of aluminum, the cell potential will also increase. If we increase the concentration of aluminum, the cell potential will also increase. So the correct answer is 3. Correct answer is 3. Fatima, okay, what do you need me to tell you? My class will be day after tomorrow. Concentration is directly proportional to, it's not always true. For reactions like this, the half cell we are talking, reduction is the half cell. Reduction half cell reaction, that one also was reduction half cell reaction. For these it is directly proportional, but you can't generalize it. I know you want tricks and all, but it doesn't take much of a time. You just write straight away, you will have an idea. Okay, you can't generalize it because sometimes there will be other, here only aluminum is there, you might have silver there also, copper also there, then what will you do? Then you'll have to calculate using this formula only. You put the value and you see which is directly proportional, which is directly related, which is indirectly related. If this was minus here, then the case would be different, right? If this was minus, then you want the low concentration, so that less amount gets subtracted from the E naught cell. Okay? Hi SP Edits, what's your name actually? So she will take your classes, don't worry. She's having an emergency at the moment, she'll come back soon. Sorry. Okay, so yeah, you can't generalize that. Next. Okay, next question. Equilibrium constant. You need to calculate the equilibrium constant. There's this nice equation written here, but you can also write it like this: log of Kc equals to N E cell, E naught cell actually, by 0. NF E naught cell by, okay, this is the equation. Normally this is the same equation, right? They have put the standard values R, T, F also, right? At 298 Kelvin. At 298 Kelvin this equation changes a little bit. At 298 Kelvin, log Kc will be equal to N E naught cell by 0.05906. Okay. I can use this equation also. Complete revision courses for KCET. Yes, we have KC30 crash course where you will be getting all the lectures there of PU1, PU2 questions, mock test, everything is there. What is your name, ma'am? My name is Ekta. Hi, Marciam. What's your name? Marcy. One shot chapter videos of yours because really you're teaching nice. Thank you. No, I don't have any one shot video actually. Okay, I'm teaching you here only, so focus here. You didn't answer, any one of you. Asha answered D. Yes, it's very simple here. Every value is given. Every value is given here. Okay, now see. Log Kc will be equal to, how many electrons are involved? Here, the reaction is actually like this. Fe3 positive, I negative, this is the reaction that is happening here. Okay, you don't need to remember this, but you can just have an idea. Fe3 positive, Fe2 positive, I negative, I2. That means here I can see one electron is involved, right? But here one I negative will lose one electron, but we are getting I2. I2 means 2 electrons are involved. So here the number of electrons are 2. Okay, so just put that value here, 2 times. E naught cell is also given 0. Oh, E naught cell we need to calculate. E naught cell will be equal to E naught cathode minus E naught anode. Here, this is your cathode. Fe3 positive is getting converted into Fe2 positive. Decrease in oxidation state. So that is what? That is your cathode. Okay, cathode. That means reduction. Here I negative is getting converted into I2. Minus 1 to 0. Minus 1 to 0. Oxidation number is increasing. That means oxidation. This is oxidation. Okay. And that means this is anode. That means this is anode. Okay. What I do need to do now? E naught cathode minus E naught anode. What is E naught cathode? Cathode is 0.76. Anode is 0.55. Clear? The answer will be 0, 1, 2. 0.21 by 0.06. Okay, if you solve this, log Kc will be equal to, say, 7. Okay, anti-log, if you take anti-log, okay, D, some of you answered D. Yes, Asha also answered D. T Sagar, correct. See, this is log Kc equals to 7. You take the anti-log. Okay, I also used to have the same problem while taking logs and anti-log. I used to get confused a lot. So it's a math question, okay, but I'll give you a trick. When log is written, when log is written, so you take anti-log will be what? Anti-log is nothing. You raise 10 raised to the power. Anti-log is nothing. You take this thing as 10 raised to the power. That is your anti-log, because log has a base of 10. Similarly, if natural logarithm is there, it has a base e. So if you apply anti-log to ln1, the natural logarithm, you do what? E raised to that number or anything that is given. You do e raised to power. Okay, here we are talking about log, so we'll take 10 raised to power. So if I take anti-log of this, Kc will be equal to 10 raised to power 7. Okay, that's a simple trick. If log 10 is there, anti-log will be 10 raised to something, 10 raised to the power. If natural logarithm is there, e raised to that power. Okay. Okay, D. Yes, the correct answer is option D. This is the correct answer. Okay. Equilibrium constant. Yeah, this formula is really important. You remember this formula. Okay. 2-3 type of questions comes from electrochemistry only. This equivalent weight 1, very easy, right? You need to match the options for the quantity of electricity in coulomb per mole required to deposit various metals at cathode. So what is happening here? See, Ag positive. If I want to deposit it at cathode, what happens at cathode? Reduction, right? That means gain of electrons. So it will gain electron and form Ag. Now, here you know one more thing, that 1 mole of electron has how much charge? 1 mole of electron has 1 Faraday. How much? 1 mole of electron, 1 Faraday. How much is 1 Faraday? 96500 coulomb per mole. Faraday is nothing, it is the charge carried by 1 mole of electrons. How many electrons are involved here? 1. So the charge will be, the electricity or the charge will be 1 Faraday. Charge will be 1 Faraday, which is 96,500 coulomb per mole. Okay, then we have Mg2 positive. For Mg2 positive, if we do reduction of Mg2 positive, it's written na, at cathode. So if we do reduction of Mg2 positive, how many electrons we need? 2 electrons, right? And we'll get Mg. So here, how much? 1 mole of electron, 1 Faraday. 2 mole of electrons, 2 Faraday, right? 2 Faraday. That means 2 times 96500. That will be 1,93,000. Okay. Third, aluminum 3 positive. Aluminum 3 positive needs how many? 3 electrons. We'll get aluminum. So the charge or electricity required is 3 Faraday. The charge required is 3 Faraday. And what is 3 Faraday? This 28,900, 2,89,500, and for the last one, this. You could have answered it using one only. A3, done. A3. Only one you need to know. Rest, all the options are different. Okay. Ma'am, into use instrument or not? Okay, you have so many A, correct. Yeah, correct. Let's finish it first, then we'll talk later. Almost there, okay? We'll talk later. Just give me a minute. Next question. How many coulombs are required to oxidize 1 mole of hydrogen to 1 mole of water to oxygen? This is water. Okay. To convert it, how many electrons it loses? Plus 4 electron, I think. Hold on a second. Array in chemistry. Yeah, sure. Okay. Okay, when you oxidize 0.1 mole of H2O2 oxygen, when you oxidize 0.1 mole of H2O2 oxygen, we need how many electrons? 2 electrons. That means around 2 Faraday you need. Around 2 Faraday. Okay. For 2 moles, 2 Faraday. Yeah. 0.1 mole of H2O. 1 Faraday. What am I writing? 1 Faraday. Okay. 2 times 0.1 mole. Yep. It will give 1 Faraday for 2 mole. It needs 1 Faraday. 0.1 mole. How much? Something is wrong with my calculations, I think. Okay, just give me a minute. Just give me a minute, huh? Yes. Delete your social media for some time, actually. That is the best you can do for yourself. Hold on a second. Okay, let's redo this question first. Okay, I got confused, I don't know why. How many coulombs are required to oxidize 0.1 mole of H2O to oxygen? So this is the reaction. H2O gives oxygen, high H positive, and 2 electrons are involved. Okay. Yes. So 1 mole, how much of H2O is this? 1 mole of H2O need how many? 2 mole of electrons, right? 2 mole of electrons means 2 Faraday. 2 Faraday of electricity. Okay. 1 mole of water. 1 mole of water needs 2 Faraday of charge, right? Faraday is in coulombs, right? 96,500 coulombs. So that much charge is required by 1 mole of water molecules. Now, how many moles are there? 0.1 mole. For 0.1 mole, it will be 2 times 96500 times 0.1. Answer will be 1.93 times 10 raised to power 4 or 5. 4, 1, 2, 3, 1. 0, 0, 0, 13, 1, 2, 3, 4, 4, yeah, it will be 4. Okay, option B. What is your message? I don't understand question 13. Yeah, I'll repeat it, don't worry. See, we need to find the coulomb. How many coulombs? How much charge is required to oxidize 0.1 mole of H2O to oxygen? We know when we oxidize water to give oxygen, we go oxidize water, we get oxygen, hydrogen ions and electrons. This is the reaction, right? This is 1 mole. This reaction is for 1 mole. For 1 mole of water molecules, we need 2 electrons, 2 mole of electrons, right? 2 mole of electrons means 2 Faraday of charge. 2 mole of electrons means 2 Faraday of charge, right? 2 Faraday of charge. How many moles are given? 0.1 mole. So what I'll do? 2 Faraday times 0.1. And if we calculate it, it comes out to be 1.93 times 10 raised to power 4 coulomb. Clear? Okay, Prajwal, for PDFs, I'll talk to ma'am. Okay, I'll talk to someone and let you know. Okay. Yes, you should actually. Once the class ends, I give you enough space to take screenshots and all. You solve the questions, please. Again, H2 water O2 fuel cell. The reaction occurring at cathode is, okay. See, old question. Anyway, so at cathode, what happens at cathode? Reduction happens at cathode. Oxygen is getting reduced to OH negative, right? It's gaining electrons. At anode, what is happening? At anode, hydrogen is getting oxidized to H2O. This is oxidation, which is loss of electrons or addition of oxygen. This is the overall reaction is simple. 2H2 plus O2 gives 2H2O. This is the overall reaction. H2O is the byproduct. That's why we use hydrogen oxygen fuel cells in spacecrafts. Okay, so what is the reaction at cathode? The reaction is simple. This one, the oxidation, the reduction of oxygen. Clear? And at anode there is oxidation of hydrogen. Anode oxidation of hydrogen, cathode reduction of oxygen. Clear? Okay, next question. Specific conductance is this. The molar conductance you need to know. We know molar conductance is related to specific conductance in this way. This is the relation, right? Molar conductance equals to kappa, which is specific conductance, times 1000 upon molarity. That is the relation we know, right? Now what values are given? Specific conductance is given 6.3 times 10 raised to power minus 2. Clear? Ohm inverse, centimeter, no, that's a different, no, centimeter inverse. Okay. Then molarity is also given, which is 0.1 m. Both these values are given. We need to calculate the molar conductance, substitute and find the value, which will be 6.3 times 10 raised to power minus 2 times 10 raised to power 3 by 10 raised to power minus 1. So the answer will be 6.3 times 10 raised to power 2, which will be 630 630. Yeah, the answer is C, 630. Ohm inverse, centimeter square, mole inverse. That is the unit of molar conductance. Okay, remember it. Unit questions will come in like match the following. Sometimes they ask. So the unit of molar conductance is ohm inverse centimeters square. It's centimeter square mole inverse. Ohm inverse centimeter square mole inverse. Okay. Yep. And for equivalent conductance, it is Simon centimeter square equivalent inverse. Simon centimeter square equivalent inverse. Simon is ohm inverse, right? You know that. C. Yeah, the questions were straightforward. C, correct. The resistance of 0.01 m KCl solution is this. If the conductivity, this is so big of a question, but it is asked only one thing. It has asked about cell constant of the conductivity cell. This is cell constant, G star. We represent it by G star. It is equals to length upon area. So it is the length of the electrode upon the area of the cross section of the electrode. Okay, area of the cross section of the electrode. That is cell. What is that? That is cell constant. Okay. Now what values we are given? We are given resistance. We are given conductivity. Okay. These two are more than enough to figure it out. Rest data you can use because there's not one. You can solve your question in multiple ways, right? You can solve it using other approach, but that's what I used. It's a simpler one for me, straightforward approach. Okay. I know. What do I know? Kappa is equals to 1 by rho. It's the reciprocal of resistivity. Okay, and somewhere I know rho is equals to, the resistivity equals to RA by L. Clear? I'll substitute these values, 1 by R, L by A. Oh, L by A is G star, that is cell constant. So I can write it as cell constant by resistance. This relation I have now, kappa equals to cell constant by resistance. So that means cell constant will be equal to kappa times resistance. What is kappa? Kappa is given, it is 0.1466 times 10 raised to power minus 3 times 1500. Okay, what will be the answer? I think it's close to option B or C. It's either option C or it's either option 219. The option is 0.219. 0.219. How many of you got the option A? B, yes. B. Okay. Clear? Let me see. Yeah, done. These are all your questions. If you have any doubts, I am here for 2-3 minutes. You can ask me. And yes, some of you were asking about the PDF one. I'll get back to you. Don't worry, Prajwal. I'll ask. And it's D. Yes, correct. So any other doubt you have? What were you guys asking about? Distraction. Yes, don't Please don't indulge in any distractions. I'm not on any social media. I keep myself occupied with other stuff. I don't go there. Why? Because it's too much distraction there. Okay, so what you should also do for your exam is in next month. Prepare accordingly, and yes, be consistent, revise properly, and every day sit down and solve questions. Every day you have to sit down. Okay, it's just less than 1 month. Okay, if you do this properly, you are going to get a really nice college. Okay, any other doubt if you have? I'm here for 2 minutes and then I'll be ending the live. These were all the questions from Solutions and Electrochemistry. If you have any other doubts, you can ask me. Okay, how to manage our schedule to score under 5,000 without crash course? Please, timetable. So it depends actually. If you have completed, like if you learned everything, you just need revision and questions. Okay, if you are on the learning phase, then that's a different thing. For learning, you need somewhere you can get all the material. If you have any playlist or one shots, you can watch where you can. If you have master socks, you can watch them also, and from there you make notes, you revise them, and then you solve questions. But if you are already learned it, then it's a better option for you. If you learned it, just revise and then solve questions. Okay, PYQs are very important. Sit down for mock test. At least before giving your real exam, sit down for 4-5 mock tests. That's the minimum I'm talking about. 4-5 mock tests. Okay. Solution question 9, 14. Oh, you remember it? Okay, we can explain. I can explain, I think. Hold on a second. 9 in solution. 9, 14. Question 7. Let me see. 7. Oh, question 7. Yeah. Okay, I'll explain again. This is the reaction, this, right? I just rewrited it. Then I identified the anode, I identified the cathode, right? Then I wrote the cell reaction. How will I calculate the E naught cell? E naught cathode minus E naught anode. But E naught anode is given, E naught cathode is not given. How will I calculate it? I will write a reaction which will give me the electrode potential of this electrode potential. So I wrote these equations, right? Random combination. You try, you hit and try, and you find this combination. This works. This is the electrode potential I need. This is the reduction potential I need. Now, what will I do? As electrode potential is not additive, I will use Gibbs free energy, because Gibbs free energy is additive and it is related to electrode potential in this way. Okay. So what did I do here actually? I wrote it like this. N3 E3 E naught 3 equals to N1 E naught 1 N2 E naught 2. N1, N2, N3, I know 1 electron, 2 electron, 1 electron, right? This is, I named them 1, 2, 3. Okay, from here I just need to know the E3. What is E3? E3 is this. See, E3 is the same as this. Okay, what did I do then? After calculating the E3, I just substituted that value here, and that's how I got my answer as how much it was. 0.38. 0.38. I hope, Girish, that's your doubt is clear for electrochemistry. PDF I'll ask, don't worry. Concentration is different. Whose concentration is different? This question. Okay, one more question, 2 other questions here, 9 and 14. 9 and 14. Okay, 14 is easy actually. You are using osmotic pressure. This is the equation for osmotic pressure. Pressure is given. Concentration, yeah, you need the molar mass. Every other data is given, but molar mass you need. R is also given, temperature is also given. So you substitute everything, pi, R, T. This concentration, in osmotic pressure, this concentration can be molality or molarity. Whatever data is given, accordingly you can calculate. The data given here is of molarity. So I calculated the molarity. Number of moles of solute, 1.26 gram. Molecular mass I don't know, that I need to figure out. Okay, and the solution is 200 ml, and I multiplied it by 1000 obviously to convert it, right? Times R times T. Okay, this is the equation. You take M this side, M on the left hand side, and substitute this on the right hand side. If you calculate it, M will come out to be 61,038. Okay, 16th one, resistance and conductivity. That doesn't influence. Hold on a second. For 16th question, where it was given? Where? Same na? 0.01, 0.01. Yes, Sagar, you can study without it. That's for like, how will I explain to you? If you're really good, if you're already there, you have already revised your syllabus multiple times, you have already learned everything there is, but still you should practice questions, okay? That is entirely possible. Some kids learn on their own, they have good good learning skills on their own, they don't even go to tuitions and all, they study themselves, okay? Some kids are like that, okay? That's normal. Okay, and if you feel like that you need a revision of PYQs, or if you need to start from your from zero you want to start your preparation, then buy the crash course, okay? And for revision also, it's very nice. You have questions, you have mock tests, everything is there. It's a very affordable range, okay? And yeah, it's for the betterment of your future. You spend that money while going out shopping, while eating, sometimes the bill is like that, na? So if it's like that investment for your future you're doing, okay, then do it, okay? And if you feel like I can study without crash course, I have all the concepts clear, I have everything, I just need to focus on PYQs, and I'll buy a mock test series. The mock test series, simple, that's all. That will work for you. You know better than me actually about yourself. Okay, one more was there. One more question, we're done. 9. This question I've explained already twice. Dimerization is happening. The Van 't Hoff factor is calculated using this equation, simple, and all the other values were given. Only the molar mass was missing. The I needed to figure out to put in this equation, right? Molality, M is the molality. Amount is given, of solute is also given, solvent is also given, right? And I just need to figure out the molar mass. That was I already explained. Dimerization, this word is important. Okay. I hope it is all clear. And again, if you have any doubts, do get back, and please practice questions. After I am ending this class now, please solve all these questions once before sitting down for your lunch. I hope you have some time. Solve once, go through all these questions, okay, without like without looking at the solutions. Solve them once and then you can have a break, okay? That I starting from 0, ma'am. Now I'm studying. That's very nice. Good. All the best. Yes. Okay. Bye everyone. Take care. All the best. Bye.